Hello, and welcome to today's lesson, Module 1.1, Numerical Expressions. Our objective is to write numerical expressions for verbal expressions, and that I can evaluate numerical expressions. What is a numerical expression? It is a mathematical phrase that includes numbers and operations, but no variables. So, for example, it could be 3 plus 5, or 7 times 8. Those are examples of numerical expressions. Now, to evaluate a numerical expression means to find its value. You are simplifying. So in the example here, 3 plus 5, it would be 8. That would be our evaluation. Now, when evaluating numerical expressions, you may come across exponents. And this is a topic that we are going to explore more fully later on in the year. But for right now, you just need to know this. A power is a base raised to an exponent. So there are two components there. The base is the factor to be multiplied, and the exponent is how many times the base is being used. So in the example on the right here, the base is 2 and the exponent is 3. So that means we are multiplying 2 by itself 3 times. So we have 2 times 2 times 2. Now, we're going to try to add in some common phrases that we use when we are talking about math and talking about expressions and the operations that we're doing. So for addition, one of these phrases, the most simple one, is simply plus. Another one would be sum. We could also talk about it being the total. We could talk about all, if we want to know how many there all are. We could use more or more than. So if we have 5 more, or we have 5 more than something else. So more and more than. These are all different words that can indicate to us that we are going to be adding. Now, if we go down to the next line, we've got subtraction. So what words can we use for subtraction? Well, one of them is minus. That's our most basic one. We could use the phrase less than. So that would be something like minus 5. Okay. There's a different phrase that's slightly confusing because it could be less, which would be like 5 minus. We say 5 less 3, it would be 5 minus 3. So that's a little bit of a tricky language piece there. We could also use a phrase like take away. Or we could even use words like fewer or difference. Now, as we move down to the next line, we are going to talk about words that can be used for multiplication. These are pretty simple. We have times, we have product, on the next line, we have words for division. So we could use quotient. Okay, we could use divide. And there might be one that you don't quite realize is applying to fraction or to division right away, and that is fraction. Because our division symbol that you see on a calculator is simply a fraction with dots that need to be filled in with two values. So the numerator, the first digit you type in is the top of the fraction, and the second digit you type in is your bottom of the fraction, the numerator and the denominator. So division is a fraction. Fraction is a division, and we are going to be using fractions a lot this year. Now, while we're on the topic of symbols, there is one symbol that you will be using, and I am requiring it. When we are talking multiplication, we are only going to be using the fraction dot. In algebra and in math classes beyond here, you will be using x as potentially a variable. So we do not want to have there being any confusion about whether you're talking about multiplying by something or whether you're including a variable of x. So from now on, you will never use the x to represent multiplication in math ever again. We are only going to be using the multiplication dot. So let's take a look at example 1 here. Our first problem is going to be translate a verbal expression. So I'm giving you something in words, and I need you to just put it into numbers and operation symbols. So we have, let's just start by looking at the problem, and let's fixate in on what are my operations that I'm having. So when I see plus, I know this is going to be an addition symbol. When I see divided, we've got a division symbol there, and now we can just put our numerals in. So we have 1 plus 8 divided by 3. Okay. In our next example, we have 18 more than 5. So more than, that was another one of our phrases that we looked at above. We have a plus sign, so we have 18 more than 5. We are adding 18 to 5. Letter C here, we've got 7 times 15 minus 2 times 9. So times, that tells us we're doing multiplication in 2 different places. And minus means we're doing some subtraction. So if we break that down, we've got 7 times 15 minus 2 times 9. Now, we're not looking at you evaluating right now. We're just translating these into the numericals. So now we have 3 you-try problems. And for these problems, I'm going to ask you to pause the video, do the work on your own, and then watch the video again and check your work to make sure that it is right. So for the first of the you-try problems, we have times, so we know we're doing multiplication. We have minus, so we're subtracting, and we have multiplication again right here. So we're going to do 3 times 12 minus 6 times 8. You try problem B, we have 20 divided by, so we're doing division, 5 plus 9. So we start off 20, division symbol, divided by 5 plus 9. And our last problem on this page, we have 8 times, so we're multiplying. We have division here, and we have subtraction. So 8 times 6 divided by 3 minus 1. Okay. Now we're going to move on to the next page in the notes. So we are going to translate a verbal expression with grouping symbols. So one way that we can phrase problems like this, we can talk about a sum or a difference or a product, and that's going to tell us what's happening. We're grouping things together. So by saying the sum of 5 and 9, okay, that's the first piece that we're working with. Sum means we're adding, so we have parentheses, 5 plus 9, and now we have is divided by, division symbol, 2. So there's 2 ways we could write this. We could write 5 plus 9, and then we do a division symbol and 2. But the way I would rather you guys write it here would be using a fraction. So we have 5 plus 9, because that's one distinct thing that we're working with, divided by 2. Our next example, we have the difference between 7 and 3. So that's telling us, the difference tells us we have 2 things that we are going to subtract, and in this case, it's 7 and 3. So it is 9 divided by 3. The difference is 7 minus 3. We put the first thing listed first, the second thing listed second. And now we have divided by again, so we have our division symbol, and I drew that in as a fraction, and we're dividing by 2. So we've got parentheses 7 minus 3 and parentheses over 2. So another way this could be phrased is if you could say the quantity 7 minus 3 over 2. So the quantity tells you that you have parentheses or grouping symbols happening there. Okay. So our last example of this one, we have the product. So we are multiplying of 4 and the sum of 9 and 7. So sum tells us we have addition again. So we have 4 parentheses 9 plus 7. Now, you'll notice that I did not put a multiplication symbol in between 4 and the parentheses. And that's because for this kind of a problem, you don't need that multiplication symbol there. A number against a parentheses or any type of grouping symbols, mathematically, we are implying, we are saying without having to write it that there is multiplication happening there. So we don't need it. If you do write a multiplication symbol, it is not going to be marked wrong. It's not the end of the world. It's just mathematicians are a little bit on the lazy side and they don't want to write that all out. So they don't. We just know that anytime you have a number next to parentheses, it's going to be multiplication. So now we have 3 you-try problems for us to work on. So go ahead, try them, pause the video, and come back and check your work when you're done. All right, so here's that one phrase that I was talking about. We're talking about 8 less than something. So if we are saying we are 8 less than, we are taking away 8, right? 8 less than is taking away 8. And we have the product, so we have multiplication of 15 and 4. So what we do is we have 15 times 4 minus 8. Our next problem here, we have twice the sum of 12 and 8. Well, twice, I know that means 2 times. So we've got sum, we know we're doing some addition here. So we have 2 times the sum of 12 plus 8. And our next problem here, we have the quotient of 5 and the sum of 12 and 3. So we have quotient, so we know we're doing division, but we also have the sum of 12 and 3, so we know we're adding in between there. So we start off with our numerator. We've got 5 over the sum of 12 and 3, 12 plus 3. Okay? So at this point, many of you should be familiar with the concept of PEMDAS, or the order of operations. And we're going to just review for a moment, what does PEMDAS mean? What does this order of operations concept mean? So first of all, parentheses, the P in PEMDAS, we are going to evaluate all expressions inside of grouping symbols. And now why do I specifically say grouping symbols and not just say parentheses? Well, because you could have parentheses, you could have brackets as a possibility. You could also have a fraction. So you would want to simplify whatever is in the numerator, simplify the denominator, and then you can compare the two. But that division is like having a grouping symbol. It's like splitting the numerator into one set of parentheses and the denominator into another set. And when we come into second semester and we start working with quadratic equations, we're going to see a lot of that kind of thing pop up where we are dealing with these more complex fractions. Now, our next one is E. Evaluate all exponents. Okay, so all of our exponents get applied. Next up, we have in red here, multiply or divide. So multiply and or divide. And we are going from the left to the right in each of the pieces that you're working with. So we work from left to right. It doesn't matter which comes first, multiplication or division. We work from the left side of the expression to the right side of the expression. Okay? And lastly, we have the blue ones. We have addition and subtraction. So that means we are going to add or subtract. And we're going to go again from left to right. So there was a mnemonic device that I know I learned when I was in 8th grade algebra, and it was, please excuse my dear Aunt Sally. So P parentheses, E exponents, multiplication, division, MD, and AS, addition and subtraction. And we are working from the left to the right always. So let's do some examples now. Our first examples on the screen here, we're going to do the top and bottom. So we have 2 to the 4th power. So that is something we need to evaluate that exponent. So if we remember back to our vocabulary, what this means is we're doing 2 times 2 times 2 times 2. Well, 2 times 2 times 2 times 2 is 16. Okay. Now, letter D here, you'll notice we've got a lot of things going on. We've got parentheses, we've got a fraction, we've got multiplication, we've got an exponent. So let's start at the beginning of what we have on our list and evaluate all expressions inside of parentheses. So the first thing we need to do, 4 plus 5 is going to give us 9. And that's still being squared. Now in our denominator, the 3 is on the outside. We're not dealing with multiplication yet. We need to finish our order of operations. So we need to do the parentheses first. 7 minus 4 is going to give me 3. Okay, so now our next step here, right, we did all of our parentheses. There's nothing left to simplify in the numerator or the denominator. Now we move on to our next step and we evaluate all exponents. There's only one exponent in this problem, and it is 9 to the 2nd power. Now 9 to the 2nd power is 9 times 9, which gives us 81. I would strongly recommend at this point that you memorize your perfect squares from 1 to 15. That will really help you as we move forward. So now in our denominator, we still have 3 times 3. And so now we're going to move forward. We're going to do simplify the denominator, right? Because we need to get rid of this fraction. So we're going to have 81 over 3 times 3 is 9. And when we simplify, 81 divided by 9 is just going to be 9. Now let's move to the middle two problems. Letter B, we have a lot of things going on again. We have an exponent, we have some parentheses, some multiplication, but we also have some addition and subtraction in here. So let's start off. We have 20. And we are subtracting 7. And then we're adding, we've got an exponent here. None of our parentheses can be simplified on the inside, so we're going to just go right to the exponent step. So we've got 8 squared is going to be 64. And then we are subtracting 7 times 11. So now we need to worry about multiplication next. So we have 20 minus 7 plus 64. And now it's 7 times 11, so we have minus 77. Okay. And now we are going to combine all of these together. We're going to work from left to right. So 20 minus 7 plus 64 minus 77, all of that is going to add up to a negative 10. Now let's work to our bottom middle question here, and we've got letter E, and it is 4 to the 3rd power. So we're going to multiply 4 times 4, which is 16, times 4 again is going to give us 64. Letter C, we have a fraction. So again, we need to remember fractions are driving to us, or they're pointing out to us that we are doing grouping symbols. So we need to simplify the numerator, and then we can simplify with the denominator. So 7 plus 5 is 12, and we have that over 3. 12 divided by 3 is going to become simply 4. And now we have letter F. Letter F, we've got parentheses going on, we've got exponents, we've got addition, subtraction, and multiplication. So we got a lot of stuff going on here. So let's start off with, and I'm going to just kind of blend two steps into one because they're not actually related to each other quite yet. So I'm going to do the step of squaring the 2. So 2 squared is 4. I'm going to do that step at the same time that I am simplifying the piece inside the parentheses here, which is 9 plus 1, which gives me 10. And the only reason I did that was just to save some time for us. So now we need to do multiplication. And let's just remember a negative sign, when we have minus 3 here, we could think of that as being plus a negative 3. And we'll talk about why that is in a little bit. But the thing that needs to stick in your mind, though, is the negative sign is being multiplied by that 10. So we're going to have 7 plus 4, and then we are subtracting 30 from that. So 7 plus 4 is 11. 11 minus 30 is negative 19. Now, there are some you-try problems here, 3 you-try problems for you. I want you to do those, pause the video, come back and check your work. All right, let's jump right in. So, letter A, we have 3 to the 5th power, so that's going to be 3 times 3 times 3 times 3 times 3. When you type that all into your calculator, you are going to get 243. Letter B, we have 12 plus 7 minus 5 squared plus 4 times 15. So let's do the same thing we did in the last problem. Let's do a little bit of combining of steps. So let's do the squaring of 5. So we have minus 25. And we are going to do the multiplication of 4 and 15, which gives us 60. Now we just have addition and subtraction from left to right. So 12 plus 7 is 19, minus 25 plus 60. We are going to end up with 54 as our simplified amount. Letter C, as we take a look at this one, we have a fraction, which again tells us we have grouping symbols, so we need to evaluate or simplify the numerator, and we need to simplify the denominator. So 23 minus 8 is going to give us 15, and we still have that over 5. 15 over 5 is going to give us a sum, or a quotient of 3. All right, so now we're going to move on to the next page, which is adding in words. I know you guys love word problems, and here's the reality of this. Word problems are the application of the skills that we are learning. So these are some of the most important problems for us to do, and that is why you will see word problems throughout this algebra curriculum that we are going to be working with, because that is the application of the skills that you are learning. So, our plans for problem solving. The first thing that, and these are universal for any problem that you are ever going to face, whether it is in school, out of school, whatever it may be, you are going to first identify and understand the task. Figure out what is it that we are trying to ask you to do. Secondly, you are going to plan your approach. How are you going to work towards solving this problem? Third, you are going to solve the problem. Do the work that you had laid out in your plan. And fourth, and the one that's most often skipped by students, is check your solution. Think about, does your answer make sense given the context of the story or whatever it is you are prompted with? Okay. Now, let's take a look at what we have here. So, example 6, write and evaluate a numerical expression. We have Melly, and she is playing skee ball at an arcade. She rolls 2 balls into the 30-point hole, 4 balls into the 20-point hole, and 3 balls into the 50-point hole. Write and evaluate an expression to find Melly's total score. So the first part of our question, our task, or our plan, is to identify and understand the task. And that's always going to be, or often going to be, in that last sentence of your problem. Write and evaluate an expression. That is what we need to do. We need to write and then evaluate an expression for the total score that Melly has. Well, let's take a look at that. If we're doing total, that tells us we are adding. We are going to be adding all of the points up that she is gathering. So she rolls 2 balls into the 30-point hole. Well, that's going to be 2 times 30, because that's what she's gotten on those first 2. 4 of them landed in the 20-point hole, so we're going to add 4 times 20. And then we were told that 3 of them landed in the 50-point hole. So then we have plus 3 times 50. So now we are going to evaluate. We wrote the expression. Great. Now we need to evaluate it. We need to figure out what was Melly's total score when she was playing skee ball. So 2 times 30, that's going to give us 60. 4 times 20 gives us 80. And 3 times 50 gives us 150. So we're going to go ahead and add these together. 60 plus 80 gives us 140, plus 150 gives us 290. 290. And it is very important to me that we include units in order to be precise with our answers here. So we are going to add in 290 points. Units are required in algebra. You will find this in all of your science classes. You will be required to include your units. An answer is not complete if you do not give me the units, because I need to know what it is you are measuring, because there are times where there may be multiple variables in a problem, and you need to be precise in telling me exactly what your answer is representing. Okay, so now we have a you-try problem of the same kind of concept. I want you guys to try it, pause the video, and then when you are done, come back and check your work against mine. All right, so our second problem here, we have a computer technician charges a flat fee of $50 plus $25 per hour. On Monday, he worked on Ika's computer for 2 hours. On Tuesday, he worked on Ika's computer for 3 hours. Write and evaluate an expression to find out the amount the computer technician charged. So, our task is to write and evaluate an expression for the charge, how much he is charging. Now, what are we measuring charge in? What do we charge people with? What value or what units do we use on how much something costs? Well, here in the United States, we use dollars. So that's our first part. So now we know we have a flat fee of $50. What that means is that's his charge just to show up and work on the computer. You are going to pay him at least $50 no matter what. And he's also charging $25 per hour. Well, he worked for 2 hours on Monday and 3 hours on Tuesday. That's a lot of work on a computer, but we're going to figure out the cost here. So we have a starting amount of 50. So I'll do that in the green, 50, because that's how much he's charging to begin with. And then he is charging by the hour, so it's 2 hours times $25. And it's 3 hours times $25. Now, some of you might be saying, well, obviously, I could just add 3 hours plus 2 hours and do 5 times 25, which is, when we come to factoring, let's remember this concept when we're looking at that you certainly could do that. But we'll get to that in second semester. So now we just need to evaluate. We wrote our expression. Now we need to evaluate it. So we do 50 plus 2 times 25, 2 times 25 is going to be another 50. And then the second day that he was working is 3 times 25, so that's 75. 50 plus 50 plus 75 is going to give us 175, and we already said that we need to include units, and we are measuring the units here in dollars. All right, we're going to move on to example 8, which is write and evaluate expressions. So, Thursdays are student days at a theater. Student tickets are $5 and popcorn refills are free. You will buy a ticket and a 20-ounce bottle of water, and you will split the cost of a large tub of popcorn and a large candy with a friend. How much money should you bring to the movie theater that day? So, our task, how much money should you bring? So if we plan our approach, I know that if I'm figuring this out, I need to add up the amount of money I'm going to spend on my ticket, plus the amount of money that I'm going to spend on that bottle of water, plus the amount that I'm going to spend on the candy and the popcorn. But we need to remember that the popcorn and candy are being split with a friend. So that tells us we're going to need to do some grouping symbols there, because you're going to take that cost and you're going to split it between you. You're going to divide it between the two of you. So our first thing we want to do is figure out, what do you pay to start? So student tickets are $5. So you are starting off paying $5. And then it says you are buying a 20-ounce bottle of water. So a 20-ounce drink is going to be another $5. Okay. Now we're going to move to the other part. You're splitting the cost of a large tub of popcorn, which is $7.50, and a large candy with a friend. So we have candy is $3.50. But you are splitting it, so that is being divided by 2. All right, so now let's do some work here. We are going to add those 2 in the front, the 5 and the 5, so we've got 10, because that isn't, there's no bearing on the rest of the problem yet. So we have a grouping symbol here, that being a division symbol. So we need to add $7.50 plus $3.50, and you are going to get a total of $11 divided by the 2 of you. So our next step is going to be doing that division. 11 divided by 2 is 5.5, or in this context, $5.50. And now we are going to figure out how much you need to bring. So we have 10 plus 5.5 is going to be 15.50. And in this context, we are dealing with dollars. Include your units. So if you want to go to the movie with that friend, bring $15.50. Now we're going to move on to the next page, the last problem in Module 1.1. So while she was on vacation, a 7-day vacation, Mrs. Hernandez boarded her dog at a local kennel. If her boarding budget is $250, can Mrs. Hernandez afford to add a daily extra walk, 1 wash, and 1 nail trimming? So can she afford a daily extra walk, a wash, and a nail trimming? That is our task. Can she afford that? So are we going to get a numerical answer as our final response? No, we're going to get a yes or no answer. Either yes, she can afford it, or no, she cannot. So let's figure it out what it is. So we know she's going to be gone for 7 days. Okay, and she's boarding the dog, so it's going to be $24 per day. So we start off with 24 times the 7 days that she's going to be gone. Now, she wants to know about all of these extras that have extra fees attached to them. So a daily extra walk is going to be $4 per day. So we need to add $4 times the 7 days that she's going to be gone. She wants to do 1 wash, and a wash is $45. That's a flat fee. So we add another $45 to it. And lastly, she wants 1 nail trimming. Nail trimmings are $12. And so we add another $12. So now we need to go through and add all of this up. Now, I typed it all into a calculator and let that do it for me. And so we've got 24 times 7 gives us 168. 168. And 4 times 7 is 28. And 45. and 12. Now we're just going to add all of those things together, and when you do, you find that the cost of 7 days of boarding plus 7 days of an extra walk plus the one wash plus the one nail trimming comes to a total of $253. So, does she have enough money in her budget to do everything that she asked? The answer is no. She would be $3 over the budget that she had planned to board her dog. Now, those are the notes for today. If you have any questions, make sure you ask when you get to class tomorrow. Have a great day.